All right, so here we're with continuous income stream. So we're going to start with a simple example having an obvious solution and generalize the concept to examples having less obvious solutions. So suppose that an aunt has established a trust that pays you $2,000 a year for 10 years. What's the total amount you receive from the trust by the end of the 10th year? And so basically we have 10 payments of $2,000 each, so you're going to get 10 times 2,000 or $20,000. Now, let's look at the same problem from a different point of view. So let's assume that the income stream is continuous at a rate of $2,000 per year. So figure 5 here on the next slide is going to be that. It's just continuous $2,000 over that 2 years, or 10 years rather. All right. So that's basically just a graph of f of t equals 2,000. That's what that is. That's y equals 2,000. That's what that graph is. And so we're going from 0 to t, and so we can have any amount of t. So t equals a quarter. What's the income going to be? Well, a quarter of 2,000, which is $500. Or what if you go, well, actually, that's supposed to be a 1 over 2, not 12 years. Somehow my fractions don't always work. So where's my mouse? All right, so a half, and that's going to be 1/2 times 2,000, which is going to be 1,000. What about t equals 1? Well, that's going to be 1 times 2,000 or 2,000. 5.3. Well, you take 5.3 times 2,000, you get 10,600. And if you do 10 years, that's going to be $20,000. So the income over a 10-year period is going to be the area under the graph of f of t equals 2,000 from 0 to 10. And how do we get that? Well, we integrate from 0 to 10 of the 2,000 dt. Well, the integral, that's 2,000 t from 10 to 0. That's going to be 10. That's going to be 0. So we get what? 20,000 again. Okay, so that's how it works, looking at it as a continuous function. And again, if you think about it, in each point in time, we can figure out what it is. And what we're doing is we're figuring out at 4, we're going to take 4 times the 2,000, so that's going to be 8,000. And so that's going to be basically the area up to that. So that would have been the area under the curve there. So length times width kind of thing. And if we took the whole thing, 10 times 2,000, that's going to give us 20,000. That's going to be the area under the curve. And so that's what we're doing with integration is we're finding the area under the curve. And so that's how this is working. All right. So let's do this one. It says, so refer to example 3 to find the total income produced to the nearest dollar during the second 5 years of operation. So the first problem is said during the first 5 years. Well, the second 5 years, that means we're going to integrate from what? Well, if we have 5 and start there, then we're going to go up to 10. And we're just going to use our function 5,000 e to the 0.04 t dt. So let's rewrite that as 5,000 integral, oops, that's a 5, not a 0. 5 to 10 of e to 0.04 t dt. Now let's let u equals 0.04 t and du is equal to 0.04 du. It's supposed to be a u, almost. There we go, maybe. And so to do that, we have to multiply this by 0.04, and we have to divide this by 0.04. So we'll have 5,000 divided by 0.04, integral from 5 to 10 of e to the u du. Well, e to the u, the integration of that, well, let's first figure out what 5,000 divided by 0.04, that's 125,000. And then it's going to be e to the u. Well, u is 0.04 t, and that's going to be gone from 5 to 10. So if we plug that in, we'll have 125,000 e to the 0.04 times 10 minus 125,000 times e to 0.04 times 5. And if we plug that into our calculator, so we have the 125,000 times, and then we'll have e to the 0.04 times 10, and then parenthesis, and then minus, and then that times 0.04 times 5 in parenthesis. And so it looks like we're going to get 33,802.74. And we're supposed to go to the nearest dollar. So that's going to be $33,803. Okay. So that's going to be your total income produced by the machine during the first 5 years, or the second 5 years of operation, because we're doing the second 5 years here. So the second 5 years from year 5 through 10. Okay, so that's going to be our solution to that one. And again, a lot of these that we're going to work in here, you're going to have to do some du substitution to do some of them. And so you'll have that to play with. So you'll get some more practice with your substitution in this section. All right, so let's stop here and come back for more.